Good morning, children. I hope all are safe with their family. Yes. Yesterday, I prepared cauliflower bhaji in my house as a evening snacks, and I had 4 or 5 immediately because bhaji was so yummy. And today morning, I was suffering from acidity problem, and remedy for that immediately I took Eno. You know what is Eno? It contains baking soda, which is a base, and immediately I got a relief. Now you can guess which topic we are going to discuss today. That is acids, bases, and salts. Acids, bases, and salts. Acid means immediately what is coming in your mind: hydrochloric acid, formula is HCl, and base, sodium hydroxide, NaOH. And now we use salt, table salt in our daily life, that is sodium chloride. So today's topic is acids, bases, and salts. And you have learned in your previous classes that the sour and bitter tastes of food are due to acids and bases respectively present in them. So acid means what is coming in your mind, it is sour in taste, and base means it is bitter in taste. And so you already know that acids are sour in taste, and the change the color of blue litmus to red, whereas bases are bitter in taste and change the color of the red litmus to blue. You can remember here one thing: acid means blue to red. Acid, it is ended with a D, and red also ended with a D. And base means it is the letter ended with the E, and blue also ended with the E. So you can remember easily blue to red and red to blue. And what is litmus? You have studied in 7th standard, I hope. It is a natural indicator. Even turmeric is also another natural indicator. You get natural this litmus from lichen tree. Have you noticed that a stain of curry on a white cloth becomes reddish brown when soap, which is basic in nature, is scrubbed on it? Suppose by mistake you just spill a little, sambar or any other kurma or something. When you rub with soap is a base. You get which color, after rubbing it off and washing, you get a yellow color. So turmeric is a natural indicator. It turns yellow when the cloth is washed with a plenty of water. You can also use synthetic indicators such as methyl orange and phenolphthalein to test for acids and bases. So two types of indicators are there. One is natural, another is synthetic. Natural means litmus and your turmeric, and artificial, that is synthetic indicator, means methyl orange and phenolphthalein. And here you see that this is litmus test you might have done in 9th standard or 8th standard. And suppose the acid, if you dip the blue litmus, it is turning to red. Acid, blue to red. And base means red to blue. So here acid is taken and blue litmus is introduced, and it is turning to red color. And here it is a base. So when you introduce a red litmus paper, it is turning to blue. So you can see nicely here one acid. This is alkali, means a dissolved base is called alkali. It is a base only, water soluble base. So pH paper you can use, or even litmus paper you can use. Red litmus paper is available in the market, and even blue litmus paper also available. So in this chapter we study the reactions of acids and bases, and how acids and bases cancel out each other's effects. That is neutralization, we say, and many more interesting things that we use and see in our day-to-day life. And litmus, you have studied in 9th, 8th standard or 7th standard. It is a solution. It is a purple dye which is extracted from lichen, a plant belonging to the division Thallophyta, and is commonly used as an indicator. When the litmus solution is neither acidic nor basic, its color is actually purple. And there are many other natural indicators I told already. Red cabbage, what we use in our house, turmeric, and colored petals such as hydrangea, petunia, geranium, which indicate the presence of acid or base in the solution. These are called acid-base indicators, or sometimes they are called as simply indicators. So litmus is a natural indicator obtained from lichen tree. One activity is given here. You have been provided with 3 test tubes. Suppose you take it as A, B, C, and one of them contains distilled water and the other 2 contains acidic solution and a basic solution respectively. So first test tube you are taking distilled water, second test tube acid, third test tube base. If you are given only red litmus paper, how will you identify the contents of each test tube? Now, you take ABC 3 test tubes, you introduce your red litmus paper. Now the first test tube, it is distilled water. Distilled water means neither acidic nor basic. The second test tube, it is acidic. So whenever you introduce blue litmus, it is turning to red. But here only red litmus is used. So no change in color occurs in the second test tube. And distilled water also it is neutral. So it is neither acidic nor basic. Third test tube, it is base. So red litmus will be turning to blue. So here the answer given, let us mark the 3 test tubes A and B and C. A drop of the solution A is put on the red litmus paper. Same is repeated with the B and C. If either of them changes color to blue, then it is basic. Therefore, out of 3, 1 is eliminated, and out of the remaining 2, any one can be acidic or neutral. Now a drop of basic solution is mixed with a drop of each of the remaining 2 solutions separately, and then the nature of the drops of the mixture is checked. If the color of the red litmus turns blue, then the second solution is neutral. If there is no change in the color, then the second solution is acidic. This is because acidic and basic solutions are neutralized each other. You understood this? So whenever acid and base both are neutralized, then there is no color change. If it is a base, then red litmus will be turning to blue. Okay, I hope you understood this. Now, understanding the chemical properties of acids and bases. Acids and bases in the laboratory. The indicators tell us whether a substance is acidic or basic by changing in color. There are some substances whose odor changes in acidic or basic media. These are called olfactory indicators. So indicators there are of 2 types. One is normal indicators that gives the color change. Another indicator is olfactory indicator. Olfactory indicator gives different smells with acids and bases. Natural indicators. Here I have shown some natural indicators. First one is lichen, and from lichen tree plant we get red litmus and blue litmus paper. Second one is turmeric. This is hydrangea, then red cabbage. Take hydrangea flowers. They are natural indicators and they are turning to pink in alkaline solution, and they show blue color in acidic soil. If the soil is acidic, then it gives the blue color. If the soil is basic, then it gives the pink color. There are some substances whose odor changes in acidic or basic media. These are called olfactory indicators, and the example for olfactory indicators are vanilla essence, onion and clove. And here you take onion. One activity is given in your textbook. Onion has a characteristic smell, you know very well. When basic solution is added to a strip treated with onion, the smell of the onion cannot be detected. That means the smell disappears. But at the same time, acid don't have any effect on onion. So using onion juice, you can identify whether the given solution is acidic or basic. And second is vanilla extract has a characteristic pleasant smell, you know very well. In basic solution, the smell cannot be detected, whereas acids don't destroy the smell. So with the help of vanilla extract, you can identify it is acidic or basic. So one related to this olfactory indicator, one activity is given in your textbook with onion. You can try in your house. Next topic is how do these acids and bases react with metals. First you take acid with metal. For this one activity is given. This is the apparatus setup given. You know very well this is the stand for holding the test tube, and test tube is fitted with cork, one hold cork. Through the cork one bent tube is introduced, and the other end of the bent tube is kept in the soap solution. So this setup we have to take. In the test tube, we have to take zinc granules and dilute sulfuric acid. Now the zinc granule reacts with this dilute sulfuric acid and hydrogen gas will be liberated. That hydrogen gas will come with the soap solution and forming a bubble. Now the soap bubbles with the hydrogen gas will rise further up, and when we introduce a burning splinter to the bubble, it bursts with a pop sound, showing the presence of hydrogen gas liberated during this reaction. So whenever a metal reacts with acid, hydrogen gas is liberated. It is lighter than air. So this activity tells that the metal reacts with acid and liberates hydrogen gas. Zinc plus dilute sulfuric acid gives zinc sulfate plus H2 gas. I hope you understood this. So now, how will you test whether it is a hydrogen gas or not? When you keep a burning matchstick or candle or something, then it burns with a pop sound. That indicates the liberation of hydrogen gas. Now note that the metal in the above reactions displaces hydrogen from acid. It is just the first chapter we discussed a displacement reaction. So here also displacement occurs. And your zinc metal is highly reactive. So that metal displaces hydrogen from sulfuric acid and hydrogen gas is liberated. And the metal combines with the remaining part of the acid and forming a compound called a salt. I think you can write the reaction between zinc and dilute sulfuric acid. Zn plus H2SO4 gives ZnSO4 zinc sulfate plus H2 gas. So acid reacts with metal and forming salt plus hydrogen gas. Now coming to the metal with base. You take same zinc granule and introduce NaOH. In that you get sodium zincate, again hydrogen gas is liberated. You find again that hydrogen is formed in this reaction. However, such reactions are not possible with all the metals because the metals they differ from one another in their characters. Characters in the sense chemical properties. Next topic is the metal carbonates and metal hydrogen carbonates with acids. Again another activity is given here. One test tube fitted with 2-hole cork, and one funnel is attached, that is a thistle funnel. It is kept in the stand, and another hole, one bent tube. The other end of the bent tube is placed in calcium hydroxide solution, that is slaked lime solution, CaOH twice solution. In this test tube, what is taken? Again sodium carbonate salt is taken and dilute hydrochloric acid is added. So what will happen? Sodium carbonate reacts with hydrochloric acid and liberates carbon dioxide, and sodium carbonate, in that sodium reacts with Cl, hydrochloric acid contains Cl and forming salt. So what gas is liberated here? CO2 gas is liberated. That CO2 gas reacts with calcium hydroxide and it turns milky. That calcium hydroxide is a colorless solution. Whenever carbon dioxide is passed through that, it turns milky. Milkiness is due to the formation of calcium carbonate. So here reaction you should understand. Zinc, here what is taken, sodium carbonate reacts with HCl, and what you get will be what? Carbon dioxide liberation and the salt plus carbon dioxide. And how will you test whether it is a carbon dioxide gas or not? You have to pass through lime water. Lime water is nothing but calcium hydroxide solution. It is watery. When you pass carbon dioxide through them, it turns milky. That indicates the liberation of carbon dioxide gas. So whenever metal carbonate or even hydrogen carbonate acid is added, carbon dioxide gas will be liberated. The reactions occurring in the above activity are written as sodium carbonate Na2CO3 and 2HCl gives 2NaCl plus water plus carbon dioxide gas. Second test tube, same manner you can take sodium bicarbonate plus HCl, you get sodium chloride plus water plus carbon dioxide. And how will you test carbon dioxide? On passing the carbon dioxide gas through lime water, that is CaOH twice plus carbon dioxide, you get a white precipitate, that is milkiness, CaCO3 plus water, calcium carbonate, and this is lime water. Again keep on passing carbon dioxide, what will happen? That calcium carbonate, again water and carbon dioxide, when you pass, it becomes colorless. It is soluble completely in water. You get calcium bicarbonate, CaHCO3 twice. I hope you understood this activity. And limestone, chalk and marble are different forms of calcium carbonate. So all metal carbonates and hydrogen carbonates react with acids to give a corresponding salt plus carbon dioxide plus water. So this is a summarized reaction. And how do acids and bases react with each other? Suppose you mix acid and base, what will happen? You take sodium hydroxide, I have shown in the first slide, NaOH and HCl, both they react. This is acid and this is base. You get sodium chloride, salt plus water. So whenever you add acid and base, you get salt plus water. This reaction we call it as neutralization. Acid is neutralized by a base and base is neutralized by acid. So base plus acid, you get salt plus water. This reaction we call it as neutralization. Here example I have shown the same slide, hydrochloric acid, sodium hydroxide, you get salt plus water. Sodium chloride plus water, NaCl. Now the reaction of metallic oxides with acids. The general reaction between metal oxides and acid can be written as, you take any metal oxide plus acid, you get again salt plus water. Since the metallic oxides react with acids to give salt plus water, similar to the reaction of base with the acid, metallic oxides are said to be basic oxides. You can remember here, metal oxides are always basic in nature. So this is basic and this is acid. So when they mix, you get salt plus water. Here also neutralization occurs. So metallic oxides react with acids to give salt plus water. And again a base with acid, same thing. You get salt plus water. Now the general reaction between non-metallic oxide means it is ulta. Non-metallic oxides. Metallic oxides you can give many examples. Calcium oxide, magnesium oxide. All the metal oxides you can give for metal oxides, iron oxide. And non-metal oxides means you can give many examples. Carbon dioxide, even sulfur dioxide. Nitrogen oxides, these are all non-metal oxides. They are acidic in nature. So whenever you introduce a base, again this is acidic, this is base, you get again salt plus water. Again this is similar to the reaction between a base and an acid. We can conclude that non-metallic oxides are acidic in nature. Now some questions you can answer. Why should curd and sour substances not be kept in brass and copper vessels? Because curd and other sour substances contain acid. Naturally they react with your utensils made up of what? Brass, copper vessels. They are nothing but metals only. That metals react with your curd which contains acid and liberates hydrogen gas, again harmful effects thereby spoiling your curd. So we should not keep curd or any sour item in the brass vessel or copper vessel. So you understood the reactivity between metal and acid. We discussed already. Again you tell your parents, not to your mother, not to keep curd or sour items in the brass or copper vessels because they liberate hydrogen, which is a harmful gas. Next, which gas is usually liberated when an acid reacts with a metal? Illustrate with an example. How will you test for the presence of a gas? Hydrogen gas is usually liberated when acid reacts with a metal. Already we discussed zinc plus dilute sulfuric acid. And how will you test that hydrogen gas? When you pass through a soap solution, hydrogen gas, when you keep a burning matchstick or a splinter near them, it bursts with a pop sound. That is an indication of the liberation of hydrogen gas. Same activity you can write here. I think you can go through this answers. Metal compound A reacts with the dilute hydrochloric acid to produce effervescence. Effervescence means whenever you open the soda bottle, it fizzes out. That is nothing but effervescence, we say. A gas evolved extinguishes a burning candle. Write a balanced chemical equation for the reaction if one of the compounds formed is calcium chloride. So calcium carbonate reacts with HCl and you get calcium chloride plus carbon dioxide and water. Effervescence means immediately you can guess it is carbon dioxide. CO2. How will you test the CO2? You have to pass through lime water. It turns milky. And what do all acids and bases have in common? How will you identify it is acid, it is base? Using a little, indicator paper, you can test it. Other way, how will you test whether it is acid or base? What is there actually in them? Why they show that color changes? Now here one activity is given. You can take one beaker with dilute hydrochloric acid, and inside one rubber cork you can keep, and two iron nails. With the help of wire they can be connected to a 6-volt battery and a bulb and a switch. Now this acid and little you can add dilute HCl is the acid. Dilute HCl means HCl with water is taken. Now this HCl liberates what? H plus ions, and bulb glows. That indicates here the current is carried through the solution by the ions. That means your HCl liberates ions. Which ions it liberates? H plus ions. So the bulb glows. Glowing of bulb indicates that there is a flow of electric current through the solution, and the electric current is carried through the solution by ions. Which ions? Here H plus and Cl minus ions. So acid means it liberates H plus. So since the cation present in acid is H plus, this suggests that acids produces H plus ions in solution, which are responsible for their acidic characters. See here what happens to an acid or a base in a water solution. So one activity is given here. One test tube you are taking and sodium chloride is taken in that, and concentrated sulfuric acid is poured to that. So sodium chloride reacts with H2SO4 and forming Na2SO4 plus HCl. So HCl gas will be liberated. How will you test whether that HCl is acidic or basic? You know very well, you have to introduce a litmus paper. Suppose when you introduce a litmus paper, blue litmus paper, dry litmus paper near the mouth of the HCl gas, it is not changed to red. Why? Because dry paper, if you use that is a litmus paper, the HCl gas will not give H plus ions. At the same time, if we keep a blue litmus paper dipped in water, that is moist litmus paper, blue litmus paper, when you keep, it is turning to, immediately it will be turning to what? Red color. So from this activity what we understand is only in water HCl releases H plus ions. So this experiment suggests that the hydrogen ions in HCl are produced in the presence of water. The separation of H plus ion from HCl cannot occur in the absence of water. So if you use a dry litmus paper, no color change. But if you use a moist litmus paper, the HCl gas dissolves in water and releases H plus ion. That changes the blue litmus to red. So HCl reacts with water and releases H plus ions. Hydrogen ions cannot exist alone, but they exist after combining with water. Thus, hydrogen ions must always be shown as H plus or hydronium ion. So we have seen that acids gives H plus ions in water. When base is dissolved in water, what will happen? When base is dissolved in water, it gives OH minus ions. Example, NaOH, it gives OH minus. Potassium hydroxide, it gives OH minus, and potassium ion, sodium ion. Magnesium hydroxide with water gives magnesium ion, and again 2 OH minus. Minus is missing. And bases generate OH minus ions in water, and bases which are soluble in water are called alkalis. All bases don't dissolve in water. An alkali is a base that dissolves in water. They are soapy to touch, bitter in taste, and highly corrosive. Never taste or touch them as they may cause harm. Okay. Now we identified that all acids generate H plus ions and all bases generate OH minus ions. And this acid and base combines and forming salt plus water. So acid releases H plus and base releases OH minus. These two combines and forming water. And the process of dissolving an acid or base in water is highly exothermic. Care must be taken while mixing concentrated nitric acid or sulfuric acid with water. The acid must always be added slowly to water with constant stirring. In chemistry lab, we prepare the dilute solution by mixing acids or bases with water. But while doing that, care should be taken because the process of dissolving an acid or base in water is highly exothermic. Exothermic means more amount of heat will be liberated. If water is added to a concentrated acid, the heat generated may cause the mixture to splash out and cause burns. So glass container may also break due to excessive local heating. So look out for the warning sign on the can of concentrated sulfuric acid on and also on the bottle of look out for the warning sign on the can of concentrated sulfuric acid and on the bottle of sodium hydroxide pellets. Mixing an acid or base with water results in the decrease in concentration of H plus ions or OH minus ions per unit volume. Such a process is called dilution, and acid or the base is said to be diluted. So while adding water to your acid or base, care should be taken because that means while diluting your acid or base, care should be taken, and especially for acids, how you should dilute your acid. You have to always take water in a container, then you have to add slowly acid to that. Care should be taken. You should not take acid in a trough and after that you should not add water. Otherwise it splashes out and more amount of heat will be liberated and it causes burn.